Hi students, this is the third part of Unit 1. This video will walk you through how to read the periodic table. Here, the periodic table are split. Okay, you can look at a periodic table. When you look at the element, you can look down the column. If the elements that are in the same column, we say that they are in the same group. Okay, for example, if you look at this lithium, sodium, potassium, rubidium, cesium, francium. These elements are in the same group. The elements that are in the same group usually have similar chemical properties. Okay, for example, like lithium, sodium, potassium. These are the elements that are very reactive. When you throw a piece of sodium into the water, they usually react very violently. Okay, and to generate heat and explosion and so on. And then over here, group number 2, this group 2, sometimes we call it 2A. These are the alkaline earth metal. Okay, so it is from beryllium down to radium. And then we're going to skip all the way to group number 3. This is 3 or 3A. Okay, and then this is group 4, 4A. 5A, 6A, 7A. Now 7A is fluorine down to astatine, and this is a new compound, a new element. Okay, and then we all usually just go down to astatine, and this is called the halogens. This group called the halogens. The last group here on the very right side of periodic table, they have this property that they are inert. They don't react with another element to form a compound. So these guys are called the inert gas or noble gases. Okay, and then in between group 2 and group 3, these are called the transition metal. And then down here, you see these pink elements. These are elements that are inserted between barium and hafnium for lanthanide to Lu. And then this is called the actinide because basically it is inserted right here. These are the elements that follow the actinide element. Okay, so these are sometimes people call them the rare earth element. Now, if you look at the periodic table, you can see that most of the elements in the table are metals, and then there are a few that are non-metals, and then these are called the metalloids. Metals have 4 unique properties. The first one here, they're very good at conducting heat and electricity. When you think about metal, I think the classic the poster child here, copper, is a very good example of metal because it conducts heat very well, conducts electricity very efficiently, and they can be hammered to thin sheets, and that is a term in chemistry we call it malleability. And then ductility is ability to pull into wires. Copper can be pulled into wires, and then metal have this nice and shiny appearance. Okay, so those are 4 unique properties of metal. Non-metals kind of like everywhere. Basically, they have this property that's not metal. And then metalloid, or sometimes we call them semi-metal. These are the elements that have the properties that is mixed between metal and non-metal. Natural state of elements. Okay, so now noble gases. Okay, let's start with noble gases. These are the elements that want to be alone. They do not react with any other element, so they exist just as a single atom in its natural state. It exists like this, you see, single atom. Okay, and then there are these 7 elements that are gas. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. These are the 7 elements that when they exist in an elemental form, they don't stay by themselves. They exist as diatomic molecule like hydrogen, It does not want to be by itself. It has to attach itself to another hydrogen and form this something called diatomic molecule. This is one molecule that composed of two atoms, like this, like that. Nitrogen, oxygen. This is one oxygen atom, another oxygen atom attached to one another to form the molecule. Okay. Now, sometimes element can attach to another atom in a unique way. So that leads to something called the allotropes. Okay, for example, carbon, the element carbon. Okay, so you can see that if the carbon atom attached to three other atoms like this, okay, and then they interact with another layer of the atoms. This is give you something called a graphite. Now, as we go into the year, I will explain what all of this mean. But right now, I just want you to see that if you have one element, they can exist in different form, and that is called the allotropes. I think this is might be a better picture to see. So you see, the diamond is composed of carbon atoms, and then graphite. Okay, graphite. When you use pencil lead, is also carbon, but they just exist in different forms. These two are allotropes to one another. So now let's take a look at this table. If you have element argon, and we know the symbol of argon is Ar. The atomic number is 18. And then it is non-metal. I'm going to use Nm for non-metal. And then the group is the noble gas. Okay. Oh, I think I misspelled it. Sorry, this is noble, and it's supposed to be NOB, noble gas. And then it is in period 3. Cl is chlorine. I hope you can read my handwriting. I'm so sorry about this. Okay. Chlorine. Atomic number of chlorine is argon's neighbor, 17. And then it is also a non-metal. And then it's the halogens. There, halogen. And then it is also in period 3. Okay, well, let's see, what is 56? 56 is barium. So the symbol is Ba. Okay, barium. I'm getting good at this. Okay, and then it is a metal. M stands for metal. Family, and then it is group number 2. Okay, 2A, and the name is alkaline earth. And then it is in period 1, 2, 3, 4, 5, 6. Okay, cesium. Okay, cesium is next to barium. Cesium is Cs. The atomic number is 55. Okay, it is also a metal, an alkali metal. Okay, alkali metal. And then it is also in period 6. Okay, and let's see, 51. What is 51? Is Sb. Oh, antimony. Oh my goodness. I got this. Antimony. Okay, so it is also, what is antimony? Let's take a look. Okay, metalloid. You can see it's right here. Okay, it's metalloid. Oh, how do I do this? Uh, I got this. Okay. It doesn't have a group name, but we know that antimony is in group 1, 2, 3, 1, 2, 3, 4, 5. It's in group number 5. It's in group 5A. Okay. All right. Next one. Let's take a look at formula of compounds. So when you have two elements, two atoms come together, and two different elements come together in certain proportion, it will produce a compound. For example, like H2O always have two hydrogen and one oxygen atom. Okay. So the type of atoms, the number of each atom and each unit molecule will give you something called a chemical formula. Now let's take a look at how to write this. Okay, so when you write a formula, each atom is represented by its element symbol. So that means you have your periodic table with you. The number of each atom are indicated by subscript, writing on lower right hand corner. And if only one atom is present, you don't have to write one. Okay, for example, like this. Okay, SO3. Okay, so it contains one sulfur atom and 3 oxygen atoms. You see, we write the 3 on the lower right hand corner of oxygen because that indicates only oxygen has 3 atoms. And then N2O5, that means that you have 2 nitrogen and 5 oxygen. Okay, so sodium sulfide here, you have 2 sodium and then 1 sulfur. Okay. And the last thing here is the ions. Sometimes the atoms will give up the electron or gain the electron. So if you have a neutral atom, okay, if it loses the electron, it will form something called a cation. Meow meow, kitty cat, cation, cation. Don't call cation, okay? It is cation. And then this is the anion. Okay, for something like sodium, okay, look at your periodic table. You can see sodium will have 11 protons, and then in the neutral state, you will have also 11 electrons. So the net charge will be equal to 0. So now, sometimes when sodium loses the electron, usually it like to lose this one electron that's far away from the nucleus, which we call valence electron. And when you lose that one electron, now the charge is not balanced because you still have 11 protons, positive charge, but you have only 10 electrons, negative charge. So that means the overall charge will be positive 1. So you write this 1 positive in upper right hand corner. Okay, so you have the sodium cation. Usually metal like to lose electron, non-metal likes to gain electron. So if you look at on the other side of periodic table, chlorine number 17, you can see it's on the right side. You can see that if chlorine in this natural state, you will have 17 proton and 17 electron. So that means that the total charge is equal to 0. So now, if the chlorine gains 1 electron, okay, so that means that now the proton will still be the same, 17. Okay, yeah, okay. Okay, so this slide is not quite right. Let's change this. Okay, so number of proton is still 17. Okay, the number of electrons you can count. Okay, so you have 18 total. So right here you have 18 total, and you can see that you have 17 positive, 18 negative. So the net charge will be negative 1. So this is something called a chloride ion. Okay, so we have Cl1 negative. And then if you look at over on in the periodic table, you can see that we have group 1, okay, like sodium, as I show you, it will lose 1 electron. Now what happened is that group 2 will also lose electron, but it will lose 2 electrons. Okay, essentially, the elements try to lose the electron so that it will have the same number of electron as is the noble gas. Okay, for example, okay, let me explain this. If you have lithium has neutral, right? So 3 protons and then 3 electrons. So now if you form lithium cation, it will still have 3 protons because it's still lithium, but now it will have only 2 electrons. That 2 electrons is similar to helium. You see that? Even like in sodium, the one that I just showed you earlier, okay, it will lose 1 electron. Initially it has 11, right? Lose 1 electron, so we have 10 electrons. So we have the same number of electron as neon. So you see that this is why group 1 will lose 1 electron, group 2 will lose 2, and then group 3 will lose 3. Okay, now if you look at the non-metal side of the periodic table, these guys likes to gain. So group 7 will gain 1 electron, so we have -1 charge. Group 6 will gain 2 negative charge. Group 5 will gain 3 electrons, we have 3 negative charge. Just like that. Okay. Okay, so we're almost done. Okay, just a little bit more. Hang in there. Now, when we have metal, okay, and non-metal, you know metal like to form the cation, non-metal likes to gain electron from an ion. When the ions are put together, you have to make sure that you balance it out in such a way so the net charge of the ionic compound is equal to 0. Okay, let's take a look over here. Remember sodium? Sodium lose the electron, okay, and then becomes sodium cation, and then chlorine gain 1 electron, okay, becomes a chloride ion. So you put 1 positive and 1 negative over here, you will have NaCl, just like that, okay. Now sometimes if you have something like magnesium, which is, group number 2, remember? Magnesium, group 2, will form charge 2 positive. Okay, so this is magnesium 2 positive. Okay, now with chlorine, it will form only 1 negative. So now that means that in order to make an ionic compound, you will need 2 negative to balance out 2 positive. So at the end, you will have a compound called MgCl2. So that 2 represents there are 2 Cl and then 1 Mg. Okay, let's try this. This is your last slide. Okay, so if you have calcium and chloride, so this would just be CaCl2. Okay, and then you have NaS2, Na, 1 positive, right? So that means you need 2 Nas total to balance out with the 2 negative charge of sulfide. It becomes Na2S. And over here, okay, so you can see that I'm going to use different color for this one. Here we use blue. You see you have calcium, 2 positive, right? You're going to need 3 of this. And then, so that it will be balanced out with the charge of phosphide. Okay, let me show you where phosphide is. Phosphide is right here. You see, it will need to gain 3 electrons to be like argon. So therefore, phosphide group 5 will have 3 negative charge. So there you have it. Okay, so this is 6 positive net, 6 negative net. So the charge balance each other out. Okay, BaO, this is 2 positive, 2 negative. This is easy peasy. So BaO. And then over here, you will need 3 potassium and then 1 phosphorus. Okay, and then over here, same case as this one, it's just opposite. Let's try different color. let's try, let's see, red. Okay, so because you have Al is 3 positive, you will need 2 of those. And then sulfide is 2 negative, right? Need 3 of those. Then you can see that we have 6 positive net and 6 negative net. So what you will have is you're going to write out as Al, 2 of them, 2, and then 3 sulfide as 3, just like that. Okay, I think you're ready to do homework 3. And yeah, that's all I have.